Hello. In this video I'm going to talk a little bit more about prime factorization, and I'm going to try to answer some of the questions. One of which is how to start. Sometimes we may get that question when we're dealing with a number which we're not familiar with. For example, if we start with number 36, then everybody knows that 36 is 6 times 6. So there's no problem with the start with this number. So what do we do if we just don't recognize the number? Let's say we have number 51. What we're going to do, we're going to run the divisibility test. If you remember, we have the divisibility test for all the numbers from 2 to 11, and some of them are prime. 2 is a prime, 3 is a prime, 5 is a prime, 7 is a prime, 11 is a prime. So we have 5 numbers and we know 5 divisibility tests. So what we're going to do, we're going to run the divisibility test, and we're going to start with the smallest prime number, 2. So we're going to run the divisibility test by 2. So 1 is odd number, therefore 51 is not divisible by 2. We're going to do divisibility test by 3. 5 plus 1 is equal to 6. 6 is divisible by 3, therefore this whole number is divisible by 3. Therefore we can write 51 as a product of 3 and some other factor. And to find this other factor, we're going to divide 51 by 3. So you may use a calculator for that. I'm just going to write down the answer, 17. So if you don't know how to start, try to run the divisibility test, and hopefully that will help. Sometimes we don't know where to start just because we're dealing with such a huge number. For example, we have 441. It's big enough for us to get stuck. So we're going to do exactly the same thing. First, we're going to run the divisibility test by 2. 1 is an odd number, therefore 441 is not divisible by 2. So now we're going to run the divisibility test by 3. 4 plus 4 plus 1 is 9. 9 is divisible by 3, therefore this number is divisible by 3. So we can write it as a product of 3 and some other factor. To find this other factor, we're going to divide 441 by 3, and you may use a calculator for that. I'm just going to write down the answer, 147. And here comes the second question, which is what to do if I get stuck. So, and the answer to that question is similar to the answer to the first question. So for example, we're dealing with this factorization, and we end up with number 147. Again, it's not small numbers, so nobody expects you to know the factorization of it. So what we're gonna do, we're gonna run the divisibility test again. Since we've already done the divisibility test by 2, there's no need for us to do it again. But we have to do divisibility by 3 test again. So let's do it again. 1 plus 4 plus 7 equals to 12. 12 is divisible by 3, therefore the whole number is divisible by 3. So we can write 147 as a product of 3 and some other number. And to find this other number, we have to divide 147 by 3. And you may use a calculator for that. I'm just going to write the answer, 49. And now we see the 49 is pretty small number, so, and we know factorization of 49, it's 7 times 7. So we have factorization of 441 is 3 times 3 times 7 times 7. Sometimes we may get stuck in the similar to the following situation. Let's say we had number 800 and 86. So it's pretty big number, so we're gonna run the divisibility test. It ends with an even number, therefore it's divisible by 2. Therefore we can write it as a product of 2 and some other number. That number is 443. And we're stuck. So what we're gonna do, we're gonna run divisibility test again. So 2 doesn't divide 443, so let's check if 3 divides 443. 4 plus 4 plus 3 is 11. 11 is not divisible by 3, therefore 443 is not divisible by 3. Since 3 is not 5 or 0, therefore 443 is not divisible by 5. So let's do the divisibility test by 7. So we have to subtract twice as much of the last digit, which is 6, from the rest of the numbers. So 44 minus 6 is 38. 38 is not divisible by 7, therefore the whole number is not divisible by 7. So let's run the last test, and we have 443. We're going to take all the odd numbered digits together, which is 7, and all the even numbered digits together, which is 4, and the difference between 7 and 4 is 3. It's not divisible by 11, therefore this whole number is not divisible by 11. So we have large number which is not divisible by any of the small primes that we know. So here's the time to check if 443 is actually a prime number. And in fact it is a prime number, so we were actually done over here. So prime factorization of 886 is 2 times 443. So the third question, most of the time people ask about some shortcuts, if there are any shortcuts in this process. You may notice the shortcuts if you know other divisibility tests. If you know divisibility test by 8 or 4 or 9. For example, let's go back to this example, 441. When we computed the sum of the digits, it was 4 plus 4 plus 1 equals 9. This number is not only divisible by 3, it is also divisible by 9. So that means that 441 is also divisible by 9. So right away we could have gotten this factorization. 441 is equal 9 times 49. And then we go from there. 9 is 3 times 3, and 49 is 7 times 7.